The Brothers Wisp. The Brothers Wisp, Brothers Wisp. The Brothers Wisp. The Brothers.
You're now listening to Greg. It's the Brothers
Hey
Wisp.
everybody,
Let's
this
take
is
a
Greg
ride.
with the Brothers Wisp. So this episode is an IPv6 specific, and it's really in response to why do I need IPv6? You know, there's a lot of misinformation and FUD associated with IPv6, and we try and dispel some of that. So on the cast today, we have some experts that have been rolling networks for years and years and years, really big ones, all the way down to folks who are like, hey, I know there's a couple of colons in there, but not much else beyond that. So a lot of really good information back and forth, some of it tangential. I hope you guys enjoy it.
And I think the takeaway from it really is that, like, it's totally doable, right? But there are some caveats, and just like with anything in networking, there's dark corners involved. And I think a couple of things kept coming up during that conversation that are very relevant here, not the least of which is an argument against that I hear all the time from folks that run enterprise networks, which is, what's the business case for it, right? And if you really want to force that question, the business case, it doesn't exist, right? I mean, if you get right down to it, the business case is probably future-proofing, right? Which most of us that run a network of any given size or have ever worked on a network that is production, it's been around for a while, know that, like, you're almost always in fireman mode, right? If it's not on fire, you don't need to touch it. And that's the reason that V6 has not really made as large of a foothold in the smaller networks as it has in, say, you know, the carriers, the national carriers, or the content providers. Which kind of brings me to the next point that folks kept saying, which is no one's asking for it and nothing is there, which is, you're never going to get anybody that asks for it, right? If you get somebody that asks for it, you probably want to question whether you want them as a customer, because they're probably like me, right?
Pain in the ass? Is that what you're doing?
Yeah, absolutely.
Customers don't know
Absolutely.
customers don't have any idea what the protocols are running. They just want the internet,
Right.
whether
So-
it runs v4 or v6.
Well,
Right, and if you do it right, they don't even know, and they don't, then they shouldn't know, right? It just gets turned on, and you're taking that path by default because it's preferred.
well, I think those are two entirely different animals, right? An enterprise versus kind of a home user sort of scenario. And I think in the enterprise too, think about it like this. I got 99 problems and IPv6 ain't one. You know what I mean? It's like I've got all these other things that I've got to be constantly dealing with. I've got all these other fires I'm putting out. And it was so hard for me to learn IPv4 to begin with. You know, how am I going to find the time or energy to dedicate myself to doing that? And then also think about this too. Say you're a small team of like 3 guys, and I put in all the effort and I learned how to do the V6. Now I'm on an island by myself because these 2 idiots that are sitting beside me don't want to take the time or go to the effort to learn it as well, right? So I know you guys have been on islands on your own, right, in the IT world, where you're the only guy that knows how to work on this thing, and you're trying to have a vacation or a semblance of a life, and you keep getting called because the thing that you're the only one who knows how to work on. You know what I mean? So it's like I hear that from people too. It's like, you know, I'm interested in doing it, but I'll be the only guy that understands how to do that. So how do you combat that?
That's a very valid statement, right? We've all been on that island, and that island sucks,
Oh,
right?
it's
You
the
don't
worst.
even have Wilson there with you to talk to. It's crummy. It's not great. But, you know, if you think about it from a resource expenditure standpoint, you've got, if you're a typical, and you're right, there's 2 different things. You got a consumer network and you got an enterprise network, right? Consumer network, they don't care, right? Give me Facebook, give me Netflix as fast as possible, best path. As long as I can get to my content, it doesn't matter to me. Enterprise is like, what's going to make me more money? What's going to cost me more money, right? And they're the ones that really are going to drive the next stage of the adoption, because consumers are already there. It's on almost all of the large carriers. It's just as the rolling process of upgrading CPE in the home that the customers own happens, it'll just be on. right? So Comcast has had it on for years now. If you don't have a piece of CPE at your house, not the cable modem, because that already supports it, because it's either a bridge or it's a router that they provide you, that all supports it, right? It's when you replace your Asus or whatever you've got at your house on your cable modem that by default asks for a prefix delegation, then you're going to have it. And yeah, the DHCP, which does exist for V6, that was another big question. As that happens, you'll just be using it as a consumer. You won't even know. It'll just be internet over a different protocol, right? And that's the way it should be. Consumers should never know about how the sausage is made. They just get the sausage. Now, the enterprises, they're very stodgy. They're very risk averse. They hate change, and they see everything as a risk, right? And that's fine, right? Because their job is not to have a network. A network is a tool to make them money. But if you start looking at the way that they build their networks, you have, probably some sort of perimeter device that's doing address translation, like an NPAT, network address port translation, which is typically just translated as NAT these days. But, a one-to-many type of deal where you have one public address or a series of public addresses and a bunch of private RC1918 space behind it. As carrier grade NAT rolls out further and further, you're not only debugging one level of NAT. Anybody that's ever had to debug a translation table knows that it's a nightmare, right? It's awful to have to debug a NAT translation table if you've ever had to do that. Now you're talking too deep. And then possibly even 3 deep if you're going with like a tier 2 or a tier 3, as the resources become less and less available on V4. So how much time you spend on that needs to be considered when you think about the effort that's involved with just rolling out V6. And it may or may not weigh out, right? It's not for everybody right now. Eventually it will be, probably around the end of my career. But and I'm being real, right? But somebody needs to be thinking about it from that point of view, because you're spending money on learning one thing, you're spending money on deploying something else, or you're spending money on triaging something, right? So you're paying people money regardless of how you think about work. It's where you want to spread that around to. And you may not have the resources to do it today, and that's okay. But learning it is only going to benefit you in the long run.
Nick, when I start seeing people that are kind of scared of what's going on, most of the time it kind of seems like it's centered around address planning. And what I finally figured out was just go grab a prefix. Don't worry about where it is and go and play. Don't worry about if you're handing 40s or 48s to somebody. Just go pick one. Go see how it works. We all know binary arithmetic, right? We've done this stuff. It's just a few more bits than it was. Go play.
Yep.
And spend the time doing it, and then go, oh, well, that was wrong. Let's go pick another prefix and do it again. Same thing you do with every machine.
Yeah, there's 2 great comments in there. One, to expand on do it again, V6 makes renumbering unbelievably easy. Like, I've renumbered a statewide networks V6 plan in the middle of the day with no outage, right? Because if you think about it from the perspective of a WISP, right, that runs microtik gear, think about MAC Telnet, right? You can get into something even without a layer 3 address as long as you have a direct layer 2 adjacency to it. V6 gives you that at layer 3 with the local addressing, right? We can talk more about how the addressing is laid out in V6, because that's another thing that people are sort of scared of because it's different. The other thing is, you're right, address planning is a big deal, because most of us that came in, even myself has been doing it since the mid-90s, I didn't come into a network that was greenfield, right, anywhere in my career. I always came into a network that already had an existing IPv4 plan. It may have been terrible, but it was already there. I didn't have to come up with it on my own. I mean, let's be real, right? A lot of that was just like stabbing in the dark. I'll just put this /24 here and this /24 there, and there was no real good plan. Yeah. If you're really lucky, there was probably spreadsheet, right? An Excel spreadsheet that people emailed around, and there was 100 different versions of it.
Yeah.
But, with V6, you get to choose, right? And just like with everything else, there's going to be 3 or 4 people that have a very strong opinion that they assert is the correct way to do, and they're probably all correct, right? It's just you pick one, and then you go with it. It's the same thing, that folks did with V4, except for at least there's a little more structure around it. And today there's tools to manage those things. There's subnet calculators. SIPCalc is a great Unix-based. There's probably a Windows port, and I know for sure there's a web-based port of that allows you to do IPv4 and IPv6 subnetting. I use it like every day. I don't do that stuff in my head. Binary math sucks. I don't want to figure out the nibble boundaries and all that. I'll use a tool to do that. So there's those things, and then there's IPAMs for address management. So you don't need to use a spreadsheet, although you can still do that. A lot of people still do, and that's okay. But there's IPAMs for managing address space allocations, and they tie in with DNS in a lot of cases.
So,
and there's free versions.
Knowing that the market we're talking to, most of the guys listening here are going to be WISPs. What's the you get 30 seconds, right? You're trapped in an elevator with somebody. You're going up 10 floors. You got 30 seconds to sell them on IPv6 for their WISP. What's the thing you're going to tell them that's really going to sell it to them?
That you can manage the paths of your customers more closely, because modern operating systems are going to tunnel IPv6 unless they're explicitly told not to. And at that point, you're going to a well-known anycast address like a 480 address or a 624 address, and that traffic is being encapsulated and sent potentially somewhere topologically far away from your network. It's happening now. If you do NetFlow queries for those anycast address, I guarantee you see traffic that's going to them on your network. You have no visibility and you have no control over that. If you deploy native IPv6, that's really the only way to get around it, because a host will always prefer native v6 over tunneled v6. So essentially, they won't tunnel anymore if you deploy it natively. Then you can control the fate and the paths and the topology of your resources.
Right. So rather than something tunneling and landing 3 states away, you can actually have it hit a local transit provider or an exchange or something like that, right? So better service for your customers, I guess, ultimately is what you're saying.
Yeah, I mean, that's probably the best selling point for it right there, because your customers are tunneling it. They don't know they're doing it. You probably don't know they're doing it unless you are explicitly looking for it, but it's happening. Things like Xboxes and stuff like that, they will always try to do that first. And your gaming customers are going to be your most vocal customers out there. If that doesn't work or if it stinks, they're playing the loudest.
Coming in on the gamers, from the gamer side and from regulatory side, the NAT issue is a really big deal too. Yeah. I'm under the impression that there's at least some of the gaming consoles that are not happy if they're double NATed. And if a regulatory person pops up and says, who had this IP address, and then you have to turn around and ask them, well, which port are you talking about?
Yeah.
If you have to go track things at that level. I mean, the carrier grade NAT's supposed to take care of that stuff for you.
I just read today that there was a court ruling that an IP address cannot be considered a person. No.
Yeah.
I mean, there's still lawful intercept. There's still lawful intercept things that you have to be aware of. Yeah. There's the notion of understanding where your folks are, and with a NAT, that's hard to do. I mean, even a carrier grade NAT, again, you're dealing with a state table that is complicated and ephemeral. If you're dealing with IPv6, it's like the old days. I don't know who here worked on networks that didn't have NAT, but I did for a very long time, and I still do. And I just cringe anytime I have to deal with an address translation table, because it's awful, right? I know it's it's sort of the de facto in most networks, but let's call it a duck, right? It sucks. Address translation sucks. It's not a security mechanism. It's a translation tool that you will have to debug eventually.
It's an auto proxy. It means that thing on the end of the network is, that's the only thing that's really on the internet. Everything else is just proxying through it. So anybody that thinks they have internet access, they really don't. They have proxy access through that NAT box.
I don't think other than outside of ISP networks, I don't think I've ever touched a network, that didn't do NAT of some sort. So I guess I'm like Bane. I was born into it, So I don't know. It's kind of like when you get a car that's fidgety. You gotta pump the gas 3 times, then you gotta turn the key a little bit, and then turn it all the way. So you just, I guess, not to say it's a good thing, but you get used to it after a while. I mean, I guess prisoners acclimate to being in prison after a while, right? So maybe it's just Stockholm syndrome.
If you had a choice, would you rather have a new car that you didn't have to fidget with the starter and push the gas pedal 4 times?
Yeah.
I mean,
I think also a big selling point for me when talking to WISPs, especially new WISPs, are, hey, I can go to this auction house and I've got to pay how much money to get an allocation of IP address space? Or, they're basically handing out the IPv6 from ARIN like Tic Tacs, right? So it's so much easier to acquire that than it is the IPv4 stuff.
Yeah, it is. It really is easy to get. And I believe, at least last time I looked, the first year was free. So as long as you've got an ARIN account, you can go and you can get your /32 of ISP allocated v6 space, and it's 0 cost for the first year. That may have changed. It's been a little while since I've looked at that. And you can play around with it, right? And a /32 is an absolute monster amount of space. I mean, it's an insane amount of address space. You can cut that in half and throw half of it away, and you'll still never fill it up.
Yeah, that was something that just really rubbed me the wrong way. Was how much address space it just goes unused in there. It's just it's hard to adapt from that. When you've gotten so used to having to scrimp and save, all of a sudden you're Scrooge McDuck and you're swimming around in your big vault full of IP addresses. It's just
takes a different mindset.
Yeah,
you have to think about
it
the
absolutely
subnets themselves as being the IP addresses, not the IPs being the IP addresses.
Yeah.
And then that solves a lot of your problems.
Yeah.
That's actually a really good point.
It's sort of like guilt, I guess, more than anything else for me. It's like, oh my God, this feels terrible. But
I don't have that attribute.
Yeah.
What's guilt feel like? I don't know.
Oh, I hear psychopaths, psychopathy. That's part of it. You don't feel guilt or fear really for the most part.
You're scaring me a little bit. I want to look in the mirror now. But no, that's a good point, right? So, and that's another topic that came up is how do we track our users? So there's a couple of different ways that this can be done, and it's really a solved problem, right? So when you're an ISP and you want to allocate a resource to a customer, typically in the v4 world, you say you get 1 IP address. Or if you're a business and you're willing to give me more money, I'll give you like /29 or something, right? But in v6, you have to think about, that's a really good way that you put that. You don't think about the individual addresses because even 1/64, which is the stereotypical block that is used on a segment or a LAN or whatever, there's so many addresses, you can't use them all. So you have to think about everything as like a subnet or an IP allocation, and you just know who has each allocation rather than each address, each discrete address. And the way that you do that is allocating it, with your DHCP v6 prefix delegation system, or you can statically do it. There's a number of ways to do it, but it's a very solved problem at this point, and it's very easy to change. And then you can track them based on attributes from the query, just like you can with option 82 in DHCP, so you've got like a circuit ID or whatever in there. Yep. You can do it that way. You can do it by DUID, which is sort of analogous to a MAC address in v4. So when your DHCP server, if you're nerdy and you're watching the logs, the leases, in v4 you see, this MAC address with this host name has been allocated this resource. In v6 you see a DUID, which is a unique identifier to whatever's made the request for the prefix. And then inside the network, that's inside the customer's network, you don't really care, right? They can do it any number of ways. It'll happen automatically.
I would say, and then, you don't care. They can do whatever they want, and they don't have to know because whatever gear they have is just going to figure it out.
Yeah. So that brings us to the notion of what's called SLAAC or Autoconfigure. And a lot of people consider this to be sort of black magic, but really what happens is your host will create an IP address based on an advertisement from the equipment. So like the router does what's called a router advertisement, and it will say, I'm the router, here's my link local address, which is sort of like a MAC address, but so it's a legitimate IPv6 address that only can exist on a layer 2 segment.
FE80.
So it's an FE80 address, right? So if you think back to the comment I made about MAC Telnet, it's what you would SSH to or Telnet to or whatever that would be equivalent to that. It's unique. It only exists on that segment, and it'll say, I'm the router, right? So if you're on that segment, you know what the router is, and from that advertisement, your machine will auto-generate a unique 128-bit address that has the network prefix that it's gotten from the router. It'll hash up the MAC address using a well-known formula and create a unique identifier that becomes its IPv6 address. And it'll just do that. It'll happen like almost instantaneously. It's not an involved process. It's just, hey, here's an advertisement. Okay, now I know what to do. I'm done. I have an IPv6 address and a route and a router, and I'm good to go.
So you were saying that it's easy to track people, but I've heard that if your computer, say, gets delegated to 64, it'll randomly use IP addresses out of that range for privacy purposes. The graphics of your web page that you load might come from one address, the text might come from another, the JavaScripts that you pull come from another one, all out of that same 64. But from an external point of view, if you were trying to trace someone down, you wouldn't exactly know that was in that 64 or a bigger or smaller delegation. So from an external point of view, it's hard to trace it. But the ISP can probably trace it because they know that delegation is going to that one person.
Yeah, that's actually a great question. And this is something that I've had to address. I'm sorry, is somebody else going to say something? I'll talk continuously if you don't stop me.
I do have a question as far as that goes. So with that in mind, kind of the privacy idea where, multiple connections can be launched from, like you were saying, you can request different parts of a web page coming from different IPs. How does a firewall track that? It's like before it used to be a single connection was created from a single IP, and kind of everything associated with that would go.
It really screws up web performance because you can't exactly keep that connection open to pipeline lots of things through it if it's creating a new connection every time it wants to grab resources.
What does that do to hotspots?
So
hotspot is not compatible at all with
MikroTik
IPv6.
V6, right? Or MikroTik's hotspot is not compatible in the least.
There is no hotspot for V6 because there is no NAT in V6.
Well, you still could. Oh.
No. It doesn't. No.
No, I was gonna say you could hard block them, but then that doesn't really accomplish what you're looking for.
No, that's why I have a problem pushing this out.
Yeah, that's a good point. Hotspot and captive portal stuff is difficult to do in V6.
I was gonna say, what's the option for
that? Is not a.
What do people do?
.1x or other options. There's not a really great option for that particular problem because it's relying on a mechanism that doesn't exist in V6, right? There's no notion of address translation.
God,
so
would you, I guess, ultimately have to, like, theoretically, if you wanted this, would you have to proxy everybody's traffic through something? Like, and then have it just grab people if they aren't authenticated? But then if
you would have to route all of the V6 traffic that goes through your network through one box and intercept it,
and if they're
really
hopping
screw stuff up.
IPs for privacy, it's like, how can they stay authenticated anymore? Without
well, you do the store delegation that they would have, but you have no way of knowing that that's the same web browser inside that network, whatever. So, it's...
So a couple things. I've never seen where different pieces of a single query are coming from different privacy addresses. In theory, that's possible.
Yeah.
And I'll explain privacy addresses here in a second. But to address the captive portal bits, the only way that I think that really can successfully be done is to do it not at layer 3, right? So you're filtering on a layer 2 address like a MAC address, which was actually the very first captive portal I ever saw was done that way, right? So it needs to be first hop. You can't just put a captive portal like somewhere out in your network.
So the captive portal has the layer 2 termination right on there. You can't go through another router.
Right.
Yeah.
Right. Because it doesn't make sense to try to filter v6 addresses when there's, billions of them.
So doesn't also IPv6 have some parts of IPsec in it that would also cause issues if you were trying to man in the middle of the communication?
In theory, I've never seen that done.
Yeah.
Right. There's all kinds of stuff that you can shove into the header of IPv6. There's lots of different things that you can do in there. Realistically speaking, in production, I've not seen that done. That was a big concern when I rolled v6 out on a very large R1 university campus. The security people were like, how do we deal with this thing? And it didn't ever really happen. Privacy addresses, however, did become somewhat of a pain. And the notion of privacy addresses is, if you think back to when I talked about, the auto-configuring of addresses based on the router advertisement, somebody somewhere said, oh my goodness, we can't be advertising our MAC addresses everywhere because that's a huge risk.
That's a unique identifier.
You don't want to compromise your OPSEC. That's right.
Which, if you're going to drive across the world and get on the same layer 2 segment, then okay, sure, fine. I won't try to bunk that too much.
That makes me laugh too when people post up like config samples that they're trying to work out and they like blur out the MAC address. It's like, dude, nobody cares.
Yeah. It's a layer 2 address, right? Yeah. And so somebody got bent out of shape about that and said, we have to figure out a way to obfuscate that. So what they did is they created a mechanism for generating temporary addresses. So if you are on a Mac and you type ifconfig and you have native IPv6, you'll see like, an FE80 address, which is your link local. You're always going to have that. You probably will have an auto-configure address and then another address that it says temporary by it. That's your security address, right? And so most of the queries will come from that. And that will rotate over time. So that's why you have to think about v6 as a prefix and not an actual address. So you route it down to where you're actually seeing the problem, and then from there you probably have to do, location wise, and then you're going to have to go and figure out which host is causing the issues. But yes, that is a problem that I would say is fairly minor, because you're going to know from an ISP perspective who has that prefix. You're just probably not going to know who has the actual host.
All right, I got the next one. Oh my God, Nick. All my things are going to be on public IP addresses now in my house. What do I do?
Nothing.
Was that an actual question? Is that legitimate?
Yeah.
I've heard that a million times. So
I don't want someone hacking my NAS because, it's sitting over here and
hacked.
There's not been any updates from the provider in forever. Or
why do people think a NAT system is so great? I mean, all it is stateful. So why not do the same thing at the entrance point to your house? Just say, you know what? I haven't talked out on this address. We don't want anyone talking in. As soon as someone talks out, it's a one-way door, opens it up and lets it in, just like any other NAT. But it's not going to actually do any translation. It's just going to keep the state.
Yeah, most of the consumer-grade devices are going to, by default, filter inbound IPv6 requests. For whatever prefix you're assigned, they'll just say, accept all outbound, but inbound, deny. And that's probably fine, because scanning even a /64 is non-trivial. And if you have somebody that really wants to get in your network, they're going to get in it, right? It's just going to happen. I worked for the FBI for a hot minute, and the thing we always said there that I learned from the ARCAT agents is, if you want a secure network, first you turn it off, then you unplug it, and then you burn it, right? That's just the way it is, right? Security is all relative. So I've had a public v6 allocation at my home, the same public v6 allocation for years, and I have no inbound filtering on it. I'd turned it all off because that's how I get into things. And I have a Bro IDS system running in the rack over there, and it's fine. I've never seen a single IPv6 event. I see tons of IPv4 events, coming in because that's easy. But v6,
Well, I mean,
they want in, they're gonna.
I think.
Yeah, they'll look at your ISP's allocations and start there, and then probably poke around. And
I like to think too that it's that IPv4 is probably the low-hanging fruit, right? That's where a lot of the Internet of Things and all that stuff is, right? So they're gonna, just like MikroTik didn't used to. You didn't see so many attacks hosted against them just because nobody knew what they were, and I feel like now that they're gaining in popularity so much, they're getting a lot more attention, and so we get all these fun little things. But also, I don't know about you guys, but the first thing I do is blow all my firewalls away when I get a new router. So who knows what's going to happen to me?
Yeah, I mean, I'm an adjunct security guy for the place I work now. I work very closely with the security team. And the thing that I see more often than anything else is drive-by stuff, right? Because most people that are trying to compromise a system understand that it's probably behind some sort of firewall. It's at the very least behind a NAT, and they can't poke at it with v4. v6 is hard to scan and difficult to manipulate because, why do it when it's probably going to be 30% of your attack surface when I can do 100% of IPv4? And so they realize that they don't need to poke inbound. The times that happens is very, very infrequent, comparatively speaking, to just a simple drive-by when they're going to a web page that may have compromised ad on it or some JavaScript code that, can exploit a browser. That's way easier to do. And frankly, that's what people need to be worried about. They don't need to be worried about some random turd scanning their IPv4. That's right. Because that's going to go on all the time.
It seems like most of the stuff I've been hearing about lately in my groups is spear phishing. Their users just keep getting emails and they keep clicking on stuff. So I guess
it's a real problem.
Should that be the FBI's new #1 thing? Kill all your employees and then turn off the network and then eventually burn it?
What was it that Randall said in the movie Clerks? So I worked at a video store in the early 90s, so he's kind of my hero. This job would be great if it wasn't for the effing customers.
Yeah, that's what they say. The world would be such a great place if it didn't have all the people in it. Yeah.
So I guess for me, we do a lot of static stuff in our network because it's IPv4 and we're very simple and it's very small and wonderful. And IPv6, there's no way I'm not Rain Man. And you guys were talking about it. And you mentioned in the Facebook post about doing DNS stuff. How does I have a DNS server set up and running like that, but what I'm just going to add in a bunch of static things for all my routers?
Yeah, I mean, so first of all, you should be doing that already with IPv4. So go do that. In IPv6, you're sort of forced to use good DNS hygiene, right? You can't memorize, unless you are Rain Man or whatever, you're not going to be able to memorize 128-bit addresses all over the place. It's just not going to happen. There's too many of them. It's a hexadecimal address that has letters and colons and stuff in it. So I gave up on that a decade ago. I used to be able to keep IPv4 addresses in my head. I don't even try to do that anymore. If it doesn't have DNS, I go figure out why it doesn't have DNS, and then I make it have DNS. And then I do an A record, a quad A record, and if it's infrastructure, it gets a PTR on both of those. For customer allocations, I don't care. Doesn't matter. Right? They're going to be ephemeral anyway. But for infrastructure stuff, you have to use good DNS hygiene.
So if you're going to do an IPv6 deployment, I guess step one is your equipment has to support it, right? Otherwise, you're not going to be able to do it in your infrastructure. But
yep.
Another thing you need is DNS that can support IPv6, right? Because things get a little bit different, right? So what are the changes as far as that goes?
It's pretty minimal, actually. If you're running bind, which is what I like to run, it's what I'm familiar with, and I know it, I've been running it since bind 4. So, it just kind of does it, right? And you can just put the records in, and the differences are really minimal, actually. You have, instead of an A record for a v4 address, it's just a quad A record. And that's
you have to have dual stack on your DNS server, or can you just have IPv4?
You can have an IPv4 only name server that can resolve IPv6 addresses all day long. And
that would be helpful if you had an IPv6 only network, because it could. Yeah.
Think about it like, do you need to have an MX network in order to get MX records?
What's that?
Do you have to be using the MX protocol in order to get MX records out of DNS? No, it runs over IPv4. Quad A records will go right over IPv4 as well. It's just a data type. It's just a
I was speaking more about the communications between the DNS client and the server.
Yeah, now if you have, so I guess we probably should have said earlier on, you're not going to deploy a v6 only network. If you are, then you probably need to reevaluate why you're doing it, because v6 only networks are going to be in an island of only v6 content, of which there is actually quite a bit at this point. All the major content providers have it. However, if you ever want to talk to the v4 world, you have to set up this sort of clunky, I'm not a fan of, set of things called NAT64, DNS 64. Now, you may be inclined to sort of go down that rabbit hole, but let me warn you right away, it will not work the way you want it to work. You're better off running a natted IPv4 infrastructure with a native IPv6 infrastructure as what they call dual stack. Your hosts won't know the difference if there's a v6 resource. So if they do a query even to a v4 name server, which is actually super common, all DNS queries happen over v4, and then if it returns a quad A record for v6, it'll just use v6 because it's native. And your customer or whatever is making that query will never see the difference.
So dual stack, carrier grade NAT on the inside for their IPv4 address, and it's going to prefer v6 whenever it can.
Always.
All right. So if I've got a DNS server, everybody listening to this should have a resolver inside, right? There's no reason for you not to have one. They're super simple to set up. I mean, it's like a 30-minute process. I run bind 9, and I started on bind 9. I'm not that old, seasoned, weathered, grizzled, however you want to explain it. So I don't have to really make any augmentations. My clients can just start pulling v6 records right off that box.
Yep. Very easy to set up.
Very nice.
And like I said, if there's v6, it's just going to use that. Dual stack is the de facto standard for deploying IPv6 at this point. So it just means you're running IPv4 and IPv6 as essentially ships in the night on your network. And it'll prefer v6 when it's available, when it won't. And when it doesn't have v6, it'll just use v4.
All right. So
and I've been running that way at my house for like a decade, right? And I'm nerdy and I have NetFlow collectors in my house and stupid things like that because I don't sleep. And
I've seen them.
I would say 60% of my, what's that?
Oh, on your NetFlow stuff, I've seen your NetFlow stuff. You've seen over one of the chats before.
Yeah.
Showing
showing
all the
90%
different
of his
networks you
traffic
talk
going
to
to
and
Pornhub. I don't know what was going on there. But
95. Come on, 95. No.
don't sell me short.
Over v6. No, it's 60% of my traffic is actually v6. And I would say that if my Roku devices did v6, which they don't, and I've shamed them for that publicly, it would probably be closer to 80.
Interesting.
So, I mean, there's a lot of content out there.
I've heard the
available.
performance can be better on IPv6 right now because there's not as much traffic running across those protocols, and some people keep the infrastructure separate or something.
I think that's subjective. I'd love to say that that's true, but my experience has been
the other. I saw
hit or miss.
I saw a presentation at Nanog 68, and the guy was doing tests of v4 networks and v6 networks. He had it set up so that there was a Google ad that would pop up in people's browser, and he made it so mundane and generic that nobody would actually click on it. But it actually ran like a little piece of JavaScript that did testing out to his servers from all over the world. And he was saying that by far v4 was more reliable. He had to make sort of guesses as to why, but he was thinking it was just that there's not as widespread adoption of v6 out there, which is probably why v4 was so much more reliable. But this was 2 years ago, right? Things change fast, so I don't know.
Yeah, I think that's probably still accurate, right? I mean, because, just like any other network upgrade, like people are not going to upgrade their little Soho router at their house until they have to, right? And so there's a lot of, but there's probably old WRT 54Gs running out there that, they're just going to do v4. And as those get replaced, that they'll start doing v6. But yeah, the adoption rate is probably a fairly good reason why that's so much lower.
All right, so I'm a WISP. I'm thinking about doing this. You just significantly simplified things. I can do dual stack, which it makes me feel more comfortable. I don't have to worry about DNS anymore. That's taken care of. What happens when I start having to troubleshooting with customers, right? I know I get this guy on the phone. I get him to the command prompt. He tells me his IP. We do some ping your default gateway, that kind of crap. How does this change with a v6 customer all of a sudden? How am I going to troubleshoot issues with these guys?
Yeah, so it will be an extra step, right? So you have to ascertain source and destination, right? Like you're going to do with any troubleshooting process that you go through, right? So I want to know where you're coming from, which may be a v6 address, and where you're going. So you can mostly route that out without having to ask them by saying, what are you trying to get to? And they're probably going to give you a web page address. You can go and you can do a dig against that and see if it has a quad A record. If it has a quad A record, then you're gonna know right away they're very likely taking v6 to this. It's going to add a couple of steps to your troubleshooting process. I'm not going to sugarcoat that. You can do a couple of other things to sort of suss out from your less technical customers, which is probably like 99% of them.
Most of them, yeah.
Go to this web page, go to IP Chicken or what is IP4.me or whatever, and it'll tell what their v4 address is, and then you have them click the button and it'll tell them what their long v6 address is if they have one. So you add that into the process of troubleshooting, like click on the v6 thing and see if they get a v6 address. So if they don't get that, it means they're not running it, right? If they or it's not working for them, right? And you can kind of go from there. But it'll add a layer of extra thought that has to go into troubleshooting that process.
All right, so work this out for me too, because this is something I've bumped into with people is, say I've got a sector, right? I've got a sector in tenant, so I've got like a /64 on that guy for customers to connect to. Some guy connects his home router to that thing, and it's got IPv6 support. What address is this guy going to pull inside? How does that v6 move through? Is he just going to explain that thought process?
So you're probably not going to put a 64 for your customers to connect to on a sector. What you're going to do is you're going to say, I want my customer, whether you're routing at that location or whether you're bridging is sort of irrelevant, right? You're either going to use a relay, or you're going to, have a DHCP server running on that segment. Probably going to use a relay, right?
So what's a DHCP relay, real quick?
Okay, so DHCP relay is when you've got multiple routers in a path, but you have one DNS server, DHCP server. So you've got a customer that says, I'm going to put this piece of equipment on your network, and it's going to ask for an IP address. I'm not going to statically configure it. If its first hop router doesn't have a DHCP server on it, you're going to have to add what's called a helper address to that, or a relay address in MikroTik terms. And that's going to be, here's the address of the DHCP server that you need to talk to. And then the piece of equipment will proxy that request. It'll basically take a broadcast and package it up as a unicast, send it to that server. That server will answer with a v4 address and a v6 prefix delegation if you're doing that, and then hand it back to the CPE.
Okay.
And then what was the question again? So that's the DHCP process.
So that's on the outside. So their outside interface pulls an IP address, right, from your addressing. What does the inside of their Soho router look like addressing-wise?
Okay, so for v6, this is where we get into the prefix delegation part, right? So when you do an IPv4, you're only able to hand out like a v4 address, a subnet mask, a gateway, and a DNS server. And if you really want to do some other things, you can do that too, but very few people do that. With v6, you can say, I want an address, but I also want you to give me a allocation of space that's more than an address. So it'll request what's called a prefix delegation. Your DHCP server will say, I know about this large block of addresses, and I am authorized to hand you out, say, like a /48 or a /56 or whatever. The DHCP process hands that back to the CPE. The CPE says, oh, I have addresses that I can use on the inside, and it'll apply those to the internal interfaces of the CPE automatically.
Gotcha. So in essence, your DHCP request now says, hey, give me a delegation of IPs I can use inside of my network. And it'll just bloop, blop, and everything's magic.
Yep.
And so,
Microchip does it. Liquidity does it. Almost everybody supports it.
And so that delegation of IPs that they're going to give to an individual home user, say my grandma with her laptop, she's going to get, what's the average delegation size that it'll hand her?
So it's variable, right? So AT&T does a /64 on a consumer grade. Comcast does, I believe, a /60, which is a handful of /64s. If you have a business class on Comcast, they give you a /56. A couple of folks that I helped out with a WISP, I set this up for them because they were interested in v6, so I just took a weekend and did it for them. And I hand out, I believe, a 60 or a 61 to all their clients. And this actually is a good data point too. On a segment, sorry, Mike, let me finish this thought real quick. On a given segment, so like a VLAN or a physical interface that's on the inside, you're going to use a /64. It's almost always going to be a /64 on a consumer
that'll be
network.
kind of the, like in an enterprise network, a /24, right? The sort of,
Yep.
That's the normal chunk you hand people.
Yeah, and that's used because for a number of reasons, but one, it's because the auto configuration of addresses doesn't work unless you're using a /64. So I'm sorry, Mike, I cut you off. What were you saying?
Oh, sure. No, and so I was going to say that ARIN actually, which different parts of the world where will have different what's the word I'm trying to think for RIRs, Internet Registries, but in the ARIN region they recommend a /48 is delegated to residential customers.
Yeah, I've seen that before.
And they do this because of and I'll let Nick go into this a little bit more because you can speak a little bit better on this. But so v6 has this thing for what they call a nimble boundary, which is groupings of prefixes essentially. You go from 64 to 56 to 48 to 40. Those are what they call the nimble boundaries every 8 bits, and they say that you shouldn't do anything not on a nimble boundary. There's no technical reason. You can still do it. It's just that's what they say you should do. And so then their thing is, if your if your home is going to have multiple subnets or multiple layers of subnets, which I don't see this happening anytime soon. They want you to be able to do 2 layers of subnets inside a home. So they say, assign a /48. And then when you want to get more addresses, they will adjust your utilization percentage based on, and I don't know the math, but based on what your smallest assigned delegation is. So if you assign all your customers a /64, they'll assume or not all, but some of them 64s. They'll assume that they're all 64s, and you still have all this, nimble boundary space left. And I went way longer than I thought I was going to on the /48.
Yeah, there's a bit of a religious debate around that, which I tend to mostly ignore. Right. My stance is you build your network the way you need to build it to be able to run it, and use best practices when you can. But this is one thing that no one can actually point to as, this is the there's not an RFC. Well, maybe there is an RFC, but if you in the ARIN number policy resource manual, their little guide of ARIN regulations, they do actually say, like, they just added it a couple of years ago. They do actually require a /48 now. Well, they say to use it.
How many 48s are in a 32?
Oh God, I don't know, dude. I use tools for that kind of thing.
I don't 65,000. I think.
I got a little bit of the math there. Okay, I actually have just put together an address plan for a WISP here in Albuquerque. Right now, they've got 37 pops that they're running. We're going to start handing 48s to every customer. We're not going to have 256 customers at a pop. They're usually under 100, well under 200, usually under 150 customers in a pop. So what we started doing was we get to the point where we can have 256 48s that we hand out to everybody, and we can do that in 256 pops. And we're only sitting at 37 pops. So what I'm really looking at is they're looking at a large change right now. They're going to have another 12 or 13 pops that are supposed to accelerate in quickly. So what we're really looking at is his future growth won't fill a quarter of the space when I'm putting 48s to everybody.
And even if it did, you can still go to ARIN and get another 32 easy peasy.
Yeah.
We can get more, or we can go change the way we're doing it for the other 3/4 of the space, or whatever else we need to do. We got lots and lots of headroom here.
Yep. So back when I started doing it, a /48 was what got assigned to like the major university I was working at, right? So we got assigned a 48 for 385 building university that had, to put it in V4 scale, we had 3 /16s and a /17, I think, and they gave us a 48, right? And that was way more than we needed. So, 48 is a lot.
48 is like a /16 of networks.
Yeah, I mean, it's a serious amount of space. If you want to give that much space to all your customers, great. You can, because like you said, it's easy to get more. I didn't do it that way because I have never done it that way. And another reason I think the nibble boundary thing is important because it makes subnetting a little bit easier. And that's, subnetting V6 is a whole other podcast in and of itself, I think. The takeaway you should get from this one is use tools to do it, right? They exist.
And it sounds like the real takeaway, for me at least, is don't worry about running out of address space. Just break it up into chunks that make sense and are logical for you and you can keep track of, right?
Yeah, it's meant to be hierarchical,
yeah,
right? That was the whole purpose of it. But, you want to give 48s out? Great, give 48s out. And another reason is sort of like in the BGP world, a /24 is sort of widely accepted as the smallest allocation that you can announce globally into BGP. That's what 48 is for V6. Sort of the, accepted allocation smallest allocation you can announce via BGP. There are obviously exceptions to that, just like there are with the v4 world, but best practice is 48. So that's another reason. But yeah, I mean, I had a VPS, a virtual machine out in California somewhere that my VPS had a 48 for one host. And that's the way he did. Every host had a 48 because he subscribed to that particular school of thought. But it's interpretable, right? If you want to do it that way, great. You don't have to. Comcast doesn't do it that way, and they're gigantic. I know WISP's probably hate hearing Comcast analogies, but I know a lot about DOCSIS networks, and so that's something that I go to because it's large and it's high profile. But you do it the way you want to run it.
So I guess like as BGP, the reason they do the /24 is for resources because nobody has a big enough table for anything smaller. Well, there's probably somebody, but whatever. But so like as far as like resource intensity, like how much should I expect my my cloud core routers to increase as far as like if I'm running them in dual stack mode? Like what, or like I guess as in general, what's like should I have two separate routers, one for each network, or is that
Layer 2 would be hard for that. There's no fast path for IPv6.
Oh.
No.
So I've done V6 on CCRs a couple of times. I've never seen an issue with it. And doing BGP, it's going to depend heavily. So you got to remember, V4 is a 32-bit address space, right? So if you're taking a full table, CCR will happily eat that, right? It'll eat the 700, 800,000 routes in V4 if you really want it to, and it won't even break a sweat in my experience with it, which I admit is fairly limited on the CCR. I mean, I've done a lot of BGP, but I've done it maybe 6 or 7 times on CCRs. For V6, it's going to depend on what kind of table you want to consume, right? Are you going to take default? Are you going to take multiple full tables? Because those are 128-bit addresses, so they will use more resources. In my experience, taking a full V6 table, one full V6 table, it's totally fine.
Yeah, but it's also
smaller.
Yeah, as you said, the number of prefixes in V4 is significant, or in V6 is significantly smaller than the V6 table, right? Or
yeah,
I can't get that straight.
It's less than 8. It's less than 8,000 routes, but they're 128-bit addresses, so it's a bigger bite of a smaller apple.
4 times the size, right?
Yeah. But I like I said, I haven't seen issues with it. The CCRs in my experience are just pretty much rock stars. I mean, they can eat a lot of stuff and do a lot of things, but I don't do complicated things with mine. I don't do QoS. I don't do any kind of weird pattern matching stuff. It's a router, and that's it.
I know in my experience, the CCRs do okay. With one peer, as soon as you start adding multiple full routes, it gets a little bit sideways. I think one full table will load in about 2 minutes or something like that, and then when you add a second table, it ups that to like 8 minutes to 10 minutes, somewhere in the neighborhood. So just every additional full load or full table you put on that sucker, it really starts slowing down. It comes down to the whole single processor has to compute all of that stuff, right? So if you're doing it on like a CHR or an x86, you'll probably get better performance. That's been beat to death.
Yeah, I mean, BGP is not typically multi-threaded, so you're gonna be limited to that, and that's true of lots of different platforms, not just ROS.
But I
probably misspoke. I was just saying BGP as a resource example, but like as IPv6 in general, how much more resource intensive is that going to be? And from the sounds of it, it's not going to be anything really.
I mean, it's going to be heavily dependent on what you're doing with that, right? If you're going to write a whole bunch of IPv6 ACLs, you need to take that into account, especially if you're running a software router, right? If you're running a Juniper or a Nokia or a CCR that is able to process some things in hardware, it's going to be less problematic, right? I like to keep my border routers as simple as possible, right? Because their job is to route. If I want to do more complicated things, first I ask myself why I want to do it, and then I hit myself in the head with a rock, tell myself I probably shouldn't do it, then I go down that path if I really need to.
And I think that's some of the advantage of V6 is being able to build simpler ACLs, because you're not taking a small amount of space and chopping it up oddly all over the place, /29 and /26s and /20 whatevers. You know, all of your management is inside this insert space, 48. All your servers are in this 48, and you're done.
Yeah, I've literally done that. Like all my point-to-point addresses, all of my loopbacks, basically all my infrastructure is in 148, and I just create an ACL that says nope, and then I'm done. It's one ACL.
So we're gonna talk about the point-to-point stuff.
Oh yeah.
Sure. Dude, I love the
64
sound
or
of my own voice.
127? That is the question. Or to 64 and implement as 127.
So to take that to what I did?
Yeah, you talk about what you did.
I mean, I did everything as 64s. Everything is allocated from space as 64s. If you want to use it as a 127, go for it. If you want to use it as a 126, so you can have, you know, 2 endpoints and radios on there too, go for it. But everything comes out of a 64. You don't track anything else.
Yep.
I don't.
That's the de facto standard, right? Is you allocate a minimum, or yeah, so you allocate a 64 for basically as the smallest resource that you want to track, and then you configure that as whatever is supported, right? So 64 used to be the agreed upon standard, and that's what that's the only thing a lot of gear would do. Now, 10 years ago, that was more the case. Today, you know, it's widely accepted that you allocate a 64 and you, if you can, configure a 127, which is the equivalent of a /30 in V6 land. So that's the way my current job, our entire backbone is done in that manner.
Can you explain why? I know why, but...
I know
yes.
why. I know why, but why don't you tell me why?
So there's a couple of reasons. One, you want to minimize the amount of hosts that can be available to build a neighbor table. Neighbor table is the V6 analogous part to like an ARP table. But in V6, obviously, there's a stupid amount of address space. So there's the notion of a neighbor table attack where you essentially run resources out. If you configure a /126 or 120, especially 127, there is no option for running out the neighbor table at that point because there's only 2 hosts. There's also, you know, to be clear, there's no broadcast, there's no network in IPv6. So there's no wasted address space. It's basically here's a host, and that's it. And they're on the same segment. That's one of the larger reasons that I've seen to do 127s. Now, the last place I worked, it's a good-sized university, the gear that we had didn't do 127s. So we did everything as 126s. And that was where we filtered we did one ACL to filter all the infrastructure stuff. And 126s are a larger address space, but still small enough that you're not going to run resources low.
All right. So in essence, in your IPAM, for every point-to-point, it's got a /64, but you'd actually configure the interface as a /127.
Yep. So the workflow we have is we allocate the /64, then we actually in the IPAM go through and give DNS to the /127 addresses. And then that's what we configure on the routers. And then we put a note in there, you know, that's the beauty of IPAMs, right? You can put a little note that says this is what this is and here's where it lives, which also should be clear from the DNS name, but for completeness.
Very nice.
So IPv6 requires ICMP not to be blocked. That's another thing. You just can't block ICMP because there's a lot of the communications there.
Well, I mean, it doesn't do ARP
between
anymore,
hosts.
right? So they had to replace it with something.
Yep. Yeah. Now, with my idealistic hat on, I would say you shouldn't block that anyway.
Yeah.
Yes.
But most people do.
There's certain
and
codes you can block and get away with.
Type 8, code 0, that kind of thing. It's okay, fine. It breaks some stuff, but it also kind of hides you a little bit. You can do filtering of ICMP with v6, but it's significantly more complicated because if you block the wrong thing, it breaks stuff that makes it really unfun to troubleshoot. Nowadays there's lots of guides that'll show you, like, here's the things that you can block with IPv6 and ICMP. And, there's big red flashing tags on it. So, be careful when you're doing this kind of thing, which you should do anytime you're blocking anything, really. But it is doable to filter ICMP, but you have to be very careful. It's not a sledgehammer like it is with v4. It's much more nuanced because it's a core part of how the protocol learns and communicates.
So, I guess in the IPv6 world, you don't really need GRE tunnels and stuff like that anymore, right? Because it's going to be public addressing to public addressing. What would be the point of that?
GRE tunnels, probably not. I've seen lots of VPLS overlays and other types of overlay technologies that transit v6.
Wouldn't your header be, instead of 20 or so, 24 bytes out of that packet, wouldn't it end up being like 128 plus? If that was the case, because the GRE tunnel would have to know where the other endpoint is.
Oh, for GRE? Yeah, I don't know. I've never done GRE encapsulation.
It would be in the header, that endpoint address.
I think the real answer is somebody will always find a reason to want to tunnel.
Great Wall of China.
No, actually, I just had a conversation about this today. What I was told from someone who was just there is that one of the most well-known ways around that is to basically just use v6 because they don't filter that. Probably for all the reasons we just talked about, or they filter it less. I have not been to China, so I can't say if that's true or not, but I was told that literally like 8 hours ago.
Or maybe it's kind of a honeypot scenario. They're just going to see if you're brave enough to try it. They're watching. No, they're watching. They're keeping tabs.
Yeah. Well, I have a coworker that was there at his last job. He just started like 6 months ago, and he said that like pretty much all VPN access just worked. There's no man in the middle. He could VPN back to his old employer, and it was unimpeded. So I don't know. It's problematic for me to go to certain countries because of my job, so I probably will not know.
A lot of FUD too.
And they're probably, there's a foreign person coming into the country. They're probably not, too worried about what they're doing versus some citizen dissident that's, Googling things you're not supposed to be Googling or whatever.
Not America.
I wouldn't even venture to guess what they're thinking.
So what's a common scenario in like an enterprise that's got remote offices to do security in between the two? What's a common implementation to do LAN-to-LAN security?
ACLs and public IPs?
No, there's
as it's going across the wire. You don't want
some kind of VPN probably, site-to-site VPN be in order.
Yeah. So just standard IPsec.
You can tunnel in an IPsec. You can get, if you're got money, you can get a carrier VPLS that just is garbage in, garbage out. They don't care what's in it. I don't know. According to all the podcasts I hear, it's all about SD-WAN. So,
which I think is so fun.
Whatever.
That's like a sexy way of saying multiple VPN connections. It's just...
yeah.
Or
I get
or does round robin NAT?
God. No, so security in v6 has been slow coming. I'm going to ignore what Mike said. Gross.
We all try to.
FIFO NAT.
No, security in v6 has actually been slow coming, but over the past 5 years or so, major firewall vendors have fairly good v6 implementations.
You just said you didn't have any firewall on your v6. So
I don't, but I have
Yeah.
had to do it in the past.
you don't even have a stateful or anything like that.
I do have a stateful appliance in there, but it's any pass all any in and out on v6. But so for example, Juniper SRX. I was my last job. I was a very early adopter of the 5800, which is the big carrier grade boxes, and one of the requirements is that had to all work with v6, right? So that's been there for a decade now, and that's trickled down into the smaller SRXs and other things on the Juniper platform. Excuse me. Cisco's got reasonable support in their ASA stuff. Palo Alto has got support in theirs. I mean, there's lots of different options. And if you don't want to if you're like me and you don't want to put impeding devices in there, Suricata supports it. BroNSM has supported it for a very long time. And those are both very scalable and very robust passive platforms.
Right. How about completely shifting gears, VoIP phones? How do those work in the v6 world? Does that get a little bit more complicated?
That's a question I really have no answer for because I do my very best to avoid any type of telephony stuff.
Yeah, well, I know like a VoIP call, generally it's one station will go through a call handler or a call manager. So whenever you actually are dialing somebody else's number, say on the same PBX, it's going to ring through the call manager. It actually does the ringing, and as soon as the call is established, somebody picks up, it makes a point-to-point link, right? So something, I guess maybe the call manager would just inform each other.
There's no more SIP ALG requirement because there's no more NAT.
Right.
So I assume a lot of these phone issues of one-way audio and things of that nature would no longer be a problem.
When you're sending the packet, because yeah, exactly what he's talking about is normally whenever you're sending a SIP packet to somebody, right, you'll go through a NAT firewall and it'll change the headers that say, it's going to this.
SIP.
It's
It
coming
rewrites
from
the
this
SIP.
source address, right? But it doesn't actually go into the data portion of the packet and say, hey, this SIP call came from this other, so it just totally bricks things sometimes.
SIP ALG does that.
Yeah,
it goes into the SIP packet and rewrites
fixes
that.
it, right? But in v6, it's like you don't have to worry
Doesn't
about
need
that
it.
anymore.
Or just makes it worse.
Well, so my guess is that oh, go ahead. Sorry.
No, I was going to say, if we've got something stateful in there, then you have all the same problems you do with NAT. You're going to have, what do they call them?
A stun server?
Related.
Not a stun. No, it's not the stun server side. The stun server side was to make sure that the translation was done right. But you need to have something that's outside of the stateful gateway for your inside phone to make a connection to, so that anybody coming in proxies through that outside box.
If somebody wants to make a call to you, then there has to be a hole poked through that thing.
Yeah, these things don't change just because we've changed that underlying protocol. Those types of things, if you've got something actively breaking connections in there because it's stateful, you're going to have your work around it somehow.
SIP ALG was specifically used because the internal LAN IP doesn't match the WAN IP, and it would rewrite it.
Right, but what he's saying
so
is...
that you don't need to do that in IPv6 stateful anymore because the private IP
my
is...
phone here on my desk, and you're trying to call me from outside. If I don't establish the connection out first, and it's a stateful firewall, you're not going to be able to come in to make that phone call to me.
I think
Exactly.
SIP is constant.
It's like,
isn't it constant communication between the two? It's kind of like a connection.
There's a bunch of keep
First David
alives
would
that
be
are
needed.
sent.
Well, no, I mean, because the call manager, you're going to have to maintain a connection to the call manager, the PBX, right? So the initial call will come through that, but then normally it switches over and you go point to point. So there must be something in there for that.
If you have
My
a
guess is
router,
that.
okay, you're going to have a router in between you and the person you're talking to. If your router won't allow a connection to your phone because you didn't initiate a connection out on that port yet,
It's related.
because it's doing stateful. Related how?
I bet if we Google
Just-
this,
it-
you
it-
have
it-
the answer in
Between
30
the two
seconds.
IP addresses, because you've got the SIP server and your phone, and there's already been outbound communication from the phone to the SIP server. So when a communication comes back, it's related.
Now, if you can have that type of piece in there, yes. But otherwise, it has to, the audio has to go through the SIP server.
It,
Or
so
you have to
in
be
the case
able,
of a
or you have to do
reinvite,
something. Yeah.
I don't think SIP works exactly the same way Greg is suggesting. They don't. Two SIP phones in two different locations aren't gonna communicate directly with
That's
each other. They
100%
still
how it works.
communicate.
They will.
Well, if they're on the same PBX, probably.
No, once the call gets established, they don't go through the PBX anymore. They're communicating directly one another.
Greg's
right.
It's called a SIP reinvite gets sent, and the server says, "Okay, I've made you guys talk. Now you guys talk amongst themselves. Keep me out of it."
I was gonna say,
So if I have
the server does that,
if I have a SIP phone on Nextiva and Greg has a SIP phone on Vonage, and I call Greg, you're suggesting that my Nextiva phone will communicate directly with his phone? So I don't think it does that.
Well, no, because it'll drop to the PSTN. So
Yeah.
that's
Because that's the
that
way
won't happen.
90% of all VoIP systems work. Because you're not. I mean,
No,
Okay.
but so
Does anybody understand what a SIP border controller is?
session border controller is, yeah.
Or session border SBCs? The
Yep.
SBC is the thing that proxies you. You put an SBC outside your office network, and your phone talks to the SBC, and the SBC doesn't have anything stateful. So the phone can talk to the SBC. Your local router allows it back and forth because it initiates it inside out to the SBC, and all of the calls get proxied into the SBC. So if you have a stateful device for V6, we're going to have a session border controller, but it can run V6, it can run V4, it doesn't matter what it is. Matter of fact, if they do translations, you could actually run V6 on one side of the border controller and V4 on the other.
Or you could just DMZ the phone.
Yeah, I mean, the communication is always going to fall back to whatever the protocols that are available along the entire path, right? I mean, I know nothing about VoIP, but
it's not
I guess
that
most of the phones don't
be the
support
packet.
V6.
It's
What's
be the
that?
packet. Be
Right.
the packet. When you're a packet and you come wandering up and you come to a router and say, I'm trying to get to that phone in there, and it says, sorry, you can't go to that phone because that phone hasn't tried to talk to you first. Because it's NAT or something stateful, it's broken. Now, if you can convince the gear that is setting up the call to set up that relationship, like the related port, like Justin was saying, then life is good. But the odds are those things aren't run by the same people. If you're buying your PBX from one person and you've got your own router at the, and the router's the thing stopping it at your site, we don't have a real communication protocol between Vonage and my local router to set up that route. So people have to build things that proxy all of the audio outside of the NAT, where it's a real connection world. And then the phones connect.
I think you were trying to say it's a real combat zone. I think that's right.
But it's not going to change. I mean, it'll change in the V6 world if people don't put stateful devices out there, because then the phones can talk to each other directly.
So just remove all the firewalls. Let's do it. No more
internet
breakers.
breakers.
Was it the greatest trick the dev ever pulled was to convince everybody he was an IPv6 packet? Just got right in. Just boom. Right past everything.
I can't tell you for sure doing that pen testing that V6 is an attack vector that has been used in the past. So that's a very real statement.
Does the default config on one of the HAP ACs or HAP lights when you turn on an IPv6 include a IPv6 firewall filters?
I believe the MikroTik default is pass all on V6. So that's actually a segue into an important statement that anything you're doing on V4, when you dual stack, if it's possible and relevant, you should also do it on V6. So make sure your ACLs are, basically equal wherever possible, and make sure your policies are matching in v4 and v6, because it's another protocol you're running, and they're independent of each other. So
I'm going to read off of the MikroTik wiki in the securing your router page of the manual. Currently, IPv6 package is disabled by default. Please enable package with care, as router OS will not create any default firewall rules for IPv6 at the moment. So it's secure by default because they don't turn it on.
So do you think like in the MikroTik, do you think like the web server, do you think it's running a separate web server for v6, or do you think it's running just the same one and listening on a v6 address?
It runs and listens on the same address, I'm pretty sure.
Okay. So that means all these same vulnerabilities that we're having to patch from and protect from, be wary because it's hitting the exact same services.
Yeah. So I have a question.
It's good.
IPv6. Okay.
What's that?
I was going to ask, IPv6 UDP, is it spoofable? Just like every other. I would assume it would be. Yeah.
Yeah, UDP is UDP for the most part.
What other protocols were created to support IPv6 that might be taken advantage of, specifically like SLAAC or something like that could be exploited? What exploit vectors are there for IPv6?
So there's all the same things for v4. So if your system services are listening on v4, they're, in theory, they should also be listening on v6 when you turn them on. In practice, that's true about probably 50% of the time. It's getting better, right? So my expectation as someone that's deploying something is if I turn on SNMP, it's going to listen on v4 and v6. That's not always the case on network hardware. It's getting better. So, my practice and my advice is if you're doing it for v4, do it for v6 also. Don't leave your SNMP community as public and not ACL'd on v6. That's a dumb idea, right? So it's just an extra thing, an extra checkbox you need to think about when you're deploying stuff. As far as independent things that are specific to v6, neighbor table is the one that comes to mind the most, because it's, the thing that people talk about the most. So building up, it's basically like exploiting an ARP table, except for in v6. So it's harder to do when you're not physically on the same segment, but it is a thing that is a attack vector that you need to think about.
I guess you don't really have to worry about DHCP exhaustion, right?
Well, I mean, depending on how you configure your pools, right? If you're doing prefix delegation, then you might, potentially, I think it's a very long shot, but, it's a risk. If I was doing a risk analysis, I would write it down.
So would you be able to spoof UDP packets on IPv6 and exhaust that table that you're talking about remotely?
No,
because you would just pick some IPs out of that 64 and spoof those.
Well, but you wouldn't exhaust the neighbor table. You would essentially generate traffic from those addresses, which would be used to flood something. It's sort of another boring volumetric attack type of vector. Now, the amount of addresses that you could source that from is exponentially higher. However, when you're dealing with something like that, like a volumetric attack incoming on IPv6, very likely you're going to figure out what that /64 is, and you're going to block the whole thing, or maybe even 48 at that point. So, I don't remember who said it, but it was a very good statement of you don't think about addresses on hosts. You think about prefixes and subnets, right? Because any given host is going to have a minimum of probably 3 addresses, right? It's going to have a link local address, which is your FE80. It's going to have the auto-configured address, and it's going to have a privacy address. It may also have a DHCP v6 address, and it may have 3 or 4 privacy addresses, but only using one of them at a time. And that's per interface. That's not per host, right? So if your host if it's a server that's got a quad port NIC in it, and they all have v6 and they're all in use, you might have as many as 20 or so IPv6 addresses that are all legitimate. So that's why you think about it as a prefix. You don't think about it as an address or a host. Everything's a prefix. And when you start going through and configuring v6, that notion will sort of just be hammered into you, because you don't write a v6 address like you do a v4 address. It's not, 4.2.2.1 and that's it, right? It's 2640 : whatever slash whatever the prefix is, usually 64. You almost always have to put the 64 in there. So your mind will start to think about them as prefixes.
Do you guys know if the queuing system in MikroTik is v6 aware? Can you build queues for IPv6 addresses?
I just saw that in one of the most recent updates to Router OS that they enabled Radius to apply simple queues to IPv6 addresses. So I assume, yeah.
All right, so you would just basically add a /64 to a queue. And
Yep.
I guess their delegation as well.
I think you can do simple things, but last time I looked, you couldn't do like packet marking like I wanted to do on v6. Like that wasn't there yet. And it could be my ignorance of the platform. I could have just, it could be user error on my part. But I fumbled around with it one night, and actually a couple of nights, and I couldn't get it to do the things that I wanted it to do that were, analogous to what I was doing in v4.
I remember back in the day in some of our networks, we used to rate limit on the switch itself that the customer was coming in on, and then eventually I moved to where software, queuing actually got really easy, and I got rid of all that. I was thankful for it, and it makes you wonder if I move back to, or transitioning to v6, if the software queuing can't keep up, maybe I'll have to move back to port-based queues in the switches, to kind of keep up with that, kind of combat that.
So I was just having this conversation with somebody recently. Actually, it might have been in that ridiculously long WISP talk thread, where the way that I learned was you always want to do your filtering and your rate limiting as close to the resource as possible. So, having built a bunch of broadband networks, like wired broadband networks, we always did all that on the CPE that was at the customer's house. So we didn't do any I'm going to rate limit BitTorrent and try to do deep packet inspection to figure that stuff out. I mean, nowadays that seems like a lost cause due to encryption and things like that. But we would do, this cable modem has, this profile, which gives them, 20 megabits down and 10 megabits up or whatever, right? And you just do it as a hard limit at the CPE. And that's the way my mind tends to work. Like I want to filter as close to the customer as I possibly can. That way they don't even have the option to.
My head jumps to like an MDU scenario where you just got an Ethernet cable going into everybody's, so it's, you don't know if they're going to stick a wireless router on there. You don't know if they're just going to put a switch and have several, know, so it's sort of, it's like, how do you sort of do that, and if it is dropping one cable in, you might have, but then again, if you need hotspot, you're not going to be running v6 because it's not, there's no solution for that. So if you're doing a hotspot scenario, you'd still be sticking with v4. I was just curious about, if you wanted to do kind of throttling of some sort, give everybody 20 megs just to make sure people don't go nuts, or whatever it would happen to be, you'd probably have to try and relegate it to the port if you didn't have like a quote-unquote CPE in their space.
Yeah, that's actually exactly the scenario I was looking at doing this in, because I'd done something similar where there's a MikroTik I was just in my lab here, but MikroTik at the border, and I wanted to say each /32 IPv4 address was capable of 15 megabits per second bidirectionally, right? And when I went to do that with v6, the marking that I needed to make that happen just didn't exist. So I futzed around with it for a little while, and then I finally just gave up. Because it wasn't a production environment. It was really just, I couldn't sleep. I wanted to figure out how to do that.
We gotta get you some Ambien.
So I always tell my wife, sleep is for babies and old people. I don't need to do that.
Cousin of death.
We do our bandwidth limiting at the tower and then it's right after the APs. So we try and follow your your philosophy of getting as close to the customer, but we also we have the philosophy of CPE is crap, so don't trust it to do anything.
Some of them are.
And it works when you're cheap. So I'm looking at the IPv6 firewall in my router, and it looks like in the Mangle stuff that it does do it, at least with the way that we do it. So that gives me lots of hope. You just do your mark connection, and then you can mark your packets after that, and then you can do it by interface. So if you just have this massive switch coming in, you could say, okay, switch, each interface gets a VLAN, and then in the router you say, all right, each VLAN gets its different mark, and then you can go from there in your queues, as long as it works. Now, who knows with MikroTik, I've only been doing this a year, and I know enough to be hesitant.
One thing I've learned is that, I've been working on network equipment for 20 years, and that's one of the reasons I really like MikroTik is because every time I touch it, I learn something new that I thought it couldn't do that it actually can.
And sometimes things you shouldn't be able to do.
Well, yes,
or things you shouldn't do with them, perhaps. I've seen that a lot of times.
Yeah.
I know some people aren't going to look favorably upon this, but that's one advantage of using a triple PoE is that a MikroTik, it queues on the interface, not on an IP range. So it doesn't matter what you're putting through triple PoE, IP, V4, V6, what was the Novell's protocol or Apple Talk?
IPX,
IPX.
IPX.
Yeah.
Oh, yeah.
Yeah. Then it'll all be limited to, 4 megs in the case of what I'm looking at now.
You bringing up IPXs before we wrap things up, I wanted to say that in the old days, in the old days, we used to have to worry about IPX and Apple Talk and IP. And nowadays, and then for 20 years, we've had people that haven't had to worry about multiple protocols running on the same wires.
I love these messages you guys are putting on here. It's actually getting recorded onto the stream.
Yeah, everyone can see those.
So just keep that in
Gotta
mind
go,
as
man.
you're typing away.
Didn't know that, but hey, it is what it is.
Yeah, beautiful, beautiful. All right, so we've hit an hour and a half, so I wonder if there's any brave people that have made it this long. If you've made it this long, I think drop a note, and we've got to do something special for you.
Yeah, just to
say
let us know that you're
say
there.
Pickles. Just say that. We'll know that's the key. That's the safe word. We know you've made it all the way. So let's.
Is that the one you use with your wife?
No, it's the one she uses with me. It's like, oh my god.
He named it. He named it.
I'm Pickle Rick. Where are we at? So yeah, hour and a half. Let's get out of here. Let's put a bow on top of it. Thank you guys, everybody, for being on here. A lot of good viewpoints. I play a good idiot, so some of this I knew, but I'm not gonna lie. A lot of this were legitimate questions that I really wanted to know. So I think this was incredibly helpful. It's a great Kickstarter. I'm actually optimistic about rolling it into a couple of networks here pretty soon. I'd been hesitantly putting it off, and I think the time is now. It's time for me to get out there and to do it. So let's start in the top left corner. Mikey, if people want to get a hold of you out on the internet, how do they do that?
Patreon.com/TheBrothersWISP.
Oh, there you go. He's mixed it up. It's not PayPal anymore. And also Facebook.com/TheBrothersWISP. That is definitely Mikey. He is quick on the draw, quick straw on all of that stuff.
I wish the Facebook app would let me differentiate between posting as the Brothers Wisp or as Mike, because I'll get a comment and I'll respond and it posts as the Brothers Wisp. I'm like, I meant that as me. I think by now most people just assume it's me unless somebody else tags their name in there, but that's kind of annoying.
Fair enough. All right, Miller.
Anyway, move on.
Miller down there hiding out. If people are going to get a hold of you out on the internets, how are they going to do that?
I'm on Facebook and I'm on the Little Brothers Wisp channel, and just wanted to add, I did take a training class for IPv6 that Butch Evans gave a while ago, and it was pretty good. So that's how I learned quite a bit about IPv6. Was his training class. I think it was 2 days before Vegas. So
rock and roll, rock and roll. All right, Tommy, where are you? If people are going to get a hold of you out on the internet, if you're interested in that sort of thing, how are they going to do that?
The Brothers WISP channel. I'm on the Mimosa forums. Is probably where you'll find me most of the time. Otherwise, I'm trying to get it on the Facebook stuff, but just look me up in the channel or in the Mimosa forums. I'm William5 over there if you need help with Mimosa crap.
Alrighty, Nick, where are you at on the internet?
Yeah. So I've got a blog that I go to occasionally and write stuff. It's forwardingplane.net. I'm on all the other usual places, Twitter and all that other dumpster fire stuff. And then I hang out sometimes on the Brothers WISP Slack channel.
Sometimes, when I feel like it.
Well, I'm on there all the time, but you know, I try to keep up.
And it's, man, I'll tell you what, it's getting harder to like go away for a day and come back to get caught up. Dude, I love it.
Getting busy.
It is.
A lot of people on there.
Or if like I'm an old man.
Which has only made it worse when we bring up, okay, so how do we solve this problem? Is now more conversation. It takes time to catch up on.
And then everybody's like, "Oh, threading's horrible." It's like, it would be nice.
Yeah, it's okay. Yeah, and
it's a part of my routine.
I'm an old man now, so sometimes I go to sleep at like 9:30, and I like when I get to work in the morning. You know, I'm actually at my desk. It's like, Jesus, it takes me like 45 minutes to crawl through everything that's gone through, just in that amount of time. A bunch of night owls. Well, I mean, we've got a lot of international guys too, which is crazy. I didn't expect that, but love it. A lot of different perspectives. All right, so the guy right here, Glenn. How do people get a hold of you out on the internet?
You mean John?
John, I'm sorry.
It's all right. Best way is John at osmond.net, JOHN at osmon.net, and I hang out on the Brothers WISP, Little Brothers Slack.
That's killer. Man, you guys are the best in there. Always piping up with good stuff. I love it. All right, you can find me at gregsoul.com. Again, the Slack that they're talking about is the Patreon-only Slack. Helps keep out the riffraff. It's a dangerous world out there. You gotta take that sword with you, like in Zelda. Where else? I guess any questions, comments? Let us know if you found this IPv6 specific one interesting. I like doing these focused ones. I think it's a different take. I love having new voices, new perspectives on things. Really enjoy these. If you do too, let us know. If you want to hear more of this sort of thing, if you have any specific topics you want to hear, let us know all of that stuff. I think this was more kind of a whet your appetite sort of thing, right? To say, hey, you too can do IPv6. Don't be so afraid of it. You can take baby steps, which was my big takeaway from this, is you can take baby steps and ease your way into this stuff. So it makes me very hopeful. A lot of great information, a lot of great people, always willing to help. Each one of these cats up here, always willing to help. So never be afraid to reach out. So thank you all, and thanks everybody for listening. Remember, safe word if you made it all the way through. Thanks.
One thing.
There's always one more thing.
So since Nick mentioned his blog, I was looking through it. In the podcasts section, you don't have a link to the DNS podcast that you did with us.
Oh, we can fix that.
Oh, what a dick move!
I see all these other
that blog needs more attention. Yeah, I'll add this in there too. I have a list of things I need to add to that, and I'm just
It's like your wall of trophies.
Messing around with the microtik at night when I'm not sleeping and not updating the blog page. So, but yeah, I'll add all this in there too.
All right.
scholarship. Wireless
I'm gonna stop the recording
networking.
now.
We
Bye-bye,
talk
guys.
about equipment and methodology, so sit back and start learning. Lighten up the tower so people can start searching. Shooting up the web in neighborhoods, net surfing. We got horrible jokes, we're loud and annoying, but we're informative facts, we're not disappointing. Just give us a listen, cause fun is the mission. I'm telling you, you don't know what you are missing. Ideas and some good comedy given. If you missed the show already, don't worry, you're forgiven.